So, Lesson 3, Introduction to Vectors. The reason, by the way, I called it Introduction to Vectors is actually, technically, vectors is not part of Physics 11. So if you did it in Physics 11, Mr. Kamosi and I generally do it because otherwise in Physics 12, kids go say, what? This lets you think about it. If you're coming from a different curriculum from another country, you may or may not have seen this before, but I'll be teaching it from scratch. In physics, any quantity is either a scalar or a vector. Scalars have magnitude only. Vectors have both magnitude and direction. Some examples. Distance is a scalar, 205 centimeters. Displacement is a vector, 6.5 kilometers due west. Velocity is a vector, 12 meters per second north. I don't know. Speed is a scalar, 60 kilometers per hour. It's the speed on a major city road, or 50 kilometers an hour is the speed in the suburbs, or 30 kilometers an hour is the speed in a school zone, but we don't attach a direction. Acceleration is a vector, although often we'll treat it as a scalar if we're just trying to find the magnitude, and then we'll add the direction afterwards by saying, well, which way is it accelerating? So we're kind of sloppy with that one. 22 seconds, what goes in the blank to the right here? What scalar quantity goes there? Time, scalar. Momentum is a vector, 8.0 kilogram meters per second south. Volume is a scalar, 3.2 liters. You can't have a direction with volume, it just is. It's a magnitude only. Force is a scalar. Who remembers the units for force? Newtons. So let's say 12 newtons at 30 degrees south of west. Worker energy. Who remembers the units for worker energy? Joules. 8.3 joules. It doesn't, Kelly, it doesn't mean that scalars have to be positive. You can't have a scalar that's negative. All that means is you lost a certain amount, but it's not a direction. We had scalars like normal math. For example, 6 kilograms plus 8 kilograms is 14 kilograms. But to add vectors, Jordan, my friend, we have to add them vectorially. It is Jordan, yes? Yeah. No, yes. Yeah. Learning names. To add vectors, we must add them vectorially. And there's two ways to do that. We represent vectors with arrows, and one way of adding vectors would be to carefully draw them to scale using graph paper, a ruler, a protractor to get the angles just right, and then measuring the distance between them. And that works. It's actually how you do it on a scale map, to be quite honest. But that's a lot of work. Oh, little note. Vectors in textbooks are written in bold font. So that V and that F right there are vectors. But it's very hard to handwrite bold. I mean, you're not going to go, especially on mine. You're not going to do that, especially mine. When I do scribbles, it crosses out. So the other notation is we put an arrow above the vector. But over the years, we've gotten lazy, and Samantha, it's become just a half arrow. Okay. Oh, and although I won't test you or quiz you on this, Ashley, you may see this. The magnitude of a vector is symbolized by the absolute value sign that you may have seen in pre-calc last year, and you may have learned what's the absolute value of -3. 3, what's the absolute value of -8? Really, in physics, what you're saying is, what's the magnitude of -3? You got 3 of them. You don't care that it's to the left of the number line. You got 3. What's the magnitude of -8? You got 8 of them. And that's why we use the absolute value symbol for magnitude in physics. Again, Ashley, I'm not going to quiz or test you on that, but I'm a nerd. I'll show you. So example 1. John travels 5 kilometers west and 8 kilometers north. What's his resulting displacement? We could carefully draw them, or better yet, we could use trig. But to use trig, we have to define the rules for adding vectors. And here it is. To add 2 vectors, we draw them tip to tail. How do we add 2 vectors, Jacob? Draw them tip to tail. Alex, how do we add 2 vectors? Draw them tip to tail. Do you know how to add 2 vectors by any chance, Clifford?
Tip to tail.
Draw them tip to tail. Oh, except there's one more thing. Once you've drawn them tip to tail, the resultant is the line from the tail of the first one to the tip of the second one. The line itself ends up being tail to tip. Sorry, but we draw them tip to tail. It looks like this. Example 1. Anytime that I start doing a vector question, if I don't have a compass rose somewhere, I'll quickly draw a little compass rose, because the number of times I've got east and west mixed up would amaze you. What are we adding from example 1? We are adding 5 kilometers west, 8 kilometers north. We want to add 5 What does DULP stand for, those of you that have had me before? Draw a little picture. Vectors in particular, I never try doing in my head, unless they're in a nice straight line with each other. Okay, then maybe I'll let one direction be positive, one direction be negative. But if they're at angles, I'm drawing a picture. 5 kilometers to the west looks like this. Plus 8 kilometers north. Now, Michael, I think I told you last year, I try and draw these roughly to scale. So since 8 is almost but not quite twice as big as 5, I'll draw a line that's almost but not quite twice as long as what I think that line 5 is. So I'm going to go about like that. William, how do I add 2 vectors together? Draw them. So as a picture, it's going to look like this. The tip goes to the tail of the second one. And the resultant is from the tail of the first to the tip of the second. That's the displacement. What's that, Peter? You see a right angle here? Are you saying this is a job for trigonometry? And SOHCAHTOA works? Yes. Yes. First of all, we can find the magnitude. How can I find the magnitude of that displacement? Pythagoras. Okay. D squared equals 5 squared plus 8 squared. (25 plus 64). I squared them in my head because I'm lazy. It's the square root of 89. How many sig figs did we say we're going to write this year always? 2 or 3. So 9.4, sure. 9.43, sure. 9.434. Oh, come on. 2 or 3 sig figs. So how about 9.43? Units? Kilometers? At. At. Okay. Now I need to find the angle. Which angle? Where my vector is originating from. The angle that I want to find, the angle theta, is this one here, where my vector is starting from. How big is that angle? Well, we need to use trig. This 8, opposite, adjacent, or hypotenuse. This 5. Which trig function? Tangent. The tangent of the mystery angle equals opposite over adjacent. So the size of the angle is going to be the inverse tan of opposite over adjacent. I'm going to get 57.99. You know what? I'm pretty sure that that's actually 58 degrees. That's only the magnitude of the angle. That's not the direction. This is going to be what of what? North of south, east of west? What of what? To draw this angle, you would start out going left or west, and you would go up or north of west. This is going to be north of west. Example 2. Question? Got the next one already? Well, good. It says 10 newtons due east, 6 newtons due south, find the resultant. Now, if I had turned the page, I would definitely draw compass rose. You guys already have a north, south, east at the top of your page. I've scrolled down, and again, I get this wrong all the time. So over here, I'm going to quickly just add a north, east, south, west, and how about a little nicer east than that little terribly butchered E. Here we go. How do I add two vectors together? Draw them. Tip to tail, Petra. All right. 10 due east would look like this. 10. 6 due south. Well, Petra, 6 is almost half of 10, a little bit bigger than half, so I'll draw a line a little bit bigger than half as long. Yoink. Ish there, maybe a little long, I don't know. I think my triangle is going to look like this. 10, 6, and I think the resultant is going to be from the tail of the first to the tip of the second. There is the force resultant, FR, the resultant force. Try this one on your own. Let's see if we get the same thing. So try doing the trig, try doing the theta, try doing the Pythagoras, and try doing the what of what. Am I right? Jacob, I'm good, yeah? By the way, Bree, in terms of how much work I would need to see, I'm good with that. I'm going to assume, if you want to, if you can do Pythagoras all on your calculator and go straight to the answer, I'll assume you didn't cheat. In fact, I kind of hope most of you can do, because you've been doing Pythagoras since grade 7 or 8. If you can do it all on a good calculator, and great. And generally, as long as you show me the trig function that you use somewhere, the tangent, I'm good. And south of east, because you would start out going east, and you would go south of east to draw out that angle. I told you the other day that on your tests there will be, I call them essay questions. They're really using principles. They're using principles of physics right to explain questions. So here's an example of one. If we add displacement vectors of length 3 meters and 2 meters, what's the maximum sum and the minimum sum? And explain your answer using relevant principles of physics. If you had displacement vectors of 3 meters and 2 meters, what's the maximum sum? What's the minimum sum? How many things are they asking us to find, Cliff? Say 2.
2.
Then you know what? Let's cleverly go like this. And how about let's go max, min. There, I'm organized now. What do you think here? What is the maximum sum I can get if I have a vector of length 3 meters and a vector of length 2 meters?
5.
Jacob, you're right. What?
5.
Convince me.
If they're both going in the same direction.
And you know what? I think that diagram would be a perfectly valid proof. I think if you went sure, I would say, oh yeah, that is the biggest. What's the minimum I can make? Okay, 1 or negative 1. Since I didn't give directions, I don't think we can really quite say negative 1. I think a magnitude of 1 pointing left or pointing right. So I think if I hear you correctly, you're saying I could go 2 this way, 3 that way. I think the smallest magnitude you can make is 1. Sure, there's a perfectly, like this is why I said to the other day, not every one of these proofs are going to be like using lots of English or anything. Sometimes just going to draw a good free body diagram or a good picture. And sure. I think everything else is going to be somewhere in between those two as you swing that arm around, and you could do some trig. But Sam, I'm pretty sure the biggest is 5. Sorry, 5. That way. 5, and the smallest is, 1. Turn the page. For the 3 vectors below, draw 2a plus b plus 0.5c. How many vectors are they asking us to draw here? How many vectors are they asking us to add here? 3. So you ready? How do I add 3 vectors together? It's a trick question. Do you want to know what the real answer is? I don't. There's no way. Not simultaneously. In fact, it's even more basic than that. How do you add 3 numbers together? And the answer, Michael, is you can't. Don't write this down. Put your pencils down. There is no mathematical algorithm that you have ever learned that lets you add all 3 of those simultaneously. You have to add 2, get an answer, and then add the 3rd. Right? There's no other way. It's the same with vectors. You're going to add 2 vectors together, get an answer as a picture, and then add the 3rd. There is no way to do it otherwise. So, thankfully, all they want us to do is draw this, not solve. Okay? Here's vector A, but that's not quite what it says here. Mickey, what does it say? What's in front of the A? What do you think 2A would look like? The same as vector A, but what? twice as long. Yeah. What does it want us to add next? Yeah. Tip to tail, yes? What does it want us to add next?
0.5C.
How would I draw that? The same as C, but what?
Half.
I'm eyeballing it. You know what? As a picture, that's the resultant vector right there. Now, I haven't solved it. I haven't done the trig. If they wanted me to do the trig, they need to give me the magnitude of A and B and C. And then what I would do, Michael, is I would do the Pythagoras and tangent trig for 2A and B, get an answer, and then I would add C, but I would no longer have a right angled triangle. I'm sure I'd be using the sine law and the cosine law, and I could. I could. But they just said draw. As a picture, it would look like that. The point, Callum, is if you ever do have three vectors to add together, don't. Add together the two easiest ones first, and then add the third yuckiest one next. Is that okay? Next page. Next page? Or no? Bottom. Here we go. Is this the last one, I think? No, I got a couple more. Let's do some physics 12. Now, as an equation here, you can see good old VF equals VI plus A delta T. But read along with me. It says, an object is initially moving at 3 meters per second east. Did you guys all just turn the page? Did they give me north, east, south, west? Draw the little compass rose so you don't do a silly mistake. It's initially moving at 3 meters per second due east. It accelerates south at 1.5 meters per second squared for 4 seconds. Find V final by using vector V final equals vector V1 plus vector A times T. Say what? Claire, what's sitting right here between the VI and the A? Do you know how I add two vectors together? Draw them. Here we go. What's VI, Claire? Magnitude and direction this time. What's the initial velocity? Magnitude and direction. What does the question say? So, 3 about yay long, and east that way. Plus Ashley, what's the acceleration, magnitude, and direction?
1.5
South. And then what's time? So time is a scalar. We're going to go 4 times 1.5 meters per second squared south. The same way as up here when we went 2A, that just doubled vector A. 1.5 times 4. What's the magnitude of that going to be? 6. What direction? What did you tell me the acceleration direction was? South, and since time is a scalar, you know what? It's going to look like this. Oh. Okay. You know, the equations that we gave you in Physics 11, Jordan, it turns out they still work for funky vector stuff, too. We never actually asked you to draw pictures. You always had stuff that was a nice straight line, or the worst we gave you was something going backwards, which you, William, just made negative. Big deal. But you know what? It works. Because how would I add those two vectors together? Why, I think I would draw them tip to tail. This is going to be 3 plus 6. That's, as a picture, V final. Now let's actually get the magnitude and the direction. Square root of 45, I think, yeah? 3 squared plus 6 squared square root, sure. Magnitude 6.71. Meters per second, because it's velocity. Direction, I think, yoink, that there. Curtis, my friend, which trig function am I going to go with here? What you were doing this summer? Sure. Shift tan of 6 over 3. And I get 63.4 degrees. What of what? North of south, east of west, what of what?
South of east.
South of east. South of east. That's a little weird, Callum, because we combined Physics 11 equation that we flogged to death last year with Physics 12. Hey, I don't have to give you stuff that lines up all nice anymore. If it doesn't line up, well, then do what the equation says, which is draw them tip to tail. I like example 3. I like example 3. I like example 3. Example 3 is a nice question. Elijah, why would I say that? Did you hear me say it was going to be on a test or a quiz? I mean, you're just kind of a student who notices when a teacher tends to emphasize certain things, and you make a little note of that because you pay attention. You're good. Oh, that's good. Okay. Peter sitting back there, huh? I don't get it. You know, well, whatever. It says an airplane has an air velocity or engine velocity of 200 meters north. In still air, it will travel 200 meters per second, and we're pointing the engines so that the plane is traveling due north. Ah, but there's a crosswind blowing 60 meters per second at 35 degrees south of east. What's the plane's ground velocity or velocity relative to the ground? And here's what you want to think. The way airplanes work is their engine velocity combined with, the fancy word for combined with is plus, the wind equals, results in ground velocity. As an equation, V engine plus V wind gives V ground. Ah, Kelly, but these are vectors. So you know what? Dope. Draw a little picture. Kelly, my angel, can you read to me the engine velocity, magnitude, and direction, please? Yep. You know, hang on, before you do that, because I turned the page, and this is exactly the one that I botched last year. Let me do that. 200 meters per second due north. I totally agree, so let me draw that. Yoink. Plus. That's the magnitude. Give me the direction. You missed something. Here's what I think I heard you say, 60 meters per second at south of east. You missed something between the at and the south. That's very important. The angle. Yeah, okay, ready? Can you read to me the wind velocity, magnitude, and direction, complete direction? Scene 1, act 1, and take 2, and Kelly, action. Here we go. South of what? This is for a reason. South of what? To draw this, I'm going to draw the east first. So south of what? East. I'm going to draw a dotted line east. What of east? So down from there. How many degrees? Yes. This is how you can put together what this is supposed to look like. Where that's a 35-degree angle, and its length is about 60, so I kind of drew it roughly about 1/3 of the 200. Actually, that 200 should be a lot longer, more probably closer to that. Whatever. You see how we put all that together, Kelly? We first of all did the easy one first. I always draw the easiest vector first. Then the nasty one, I said, the of is going to be my dotted baseline, and I'm going to go whatever from that. South from of east. How am I going to add these two vectors together? Draw them. Tip to tail. Now, I know underneath here it says when we draw it, we get this picture. I'm going to draw the triangle here first, I think, because I recall from prior experience that we need lots of room to show work. So I'm going to put an equal sign. And as a picture, it's going to look like this. 200. Yoink. 60. And I think my scale's pretty good. That's about roughly 1/3 as long as the 200. Where's the resultant? Always from the tail of the first to the tip of the second. That there is what I'm trying to find. Now, Sam, it may look like there is a right angle right there. I'm not so sure. In fact, I don't think there is. This is going to be sine law, cosine law, lots of work stuff. But I can't solve this as yet. I haven't yet used that 35 degrees. Put your pencils down, look up. I'm going to muck up my diagram and then erase it. Ready? How big? Too slow. Hang on, it's going to vanish. I only got a 10-second. I'm using something that causes my ink to vanish after 10 seconds, and I know how long my explanation is going to take. So you ready? Alex, I'm going to pick on you. Are you ready? How big? How big? 90. How big? Ready? Here we go again. I only got 10 seconds. Scene 1, Act 1, Take 2. Alex, how big? How big? What's left? Okay? Because we got to get an angle into our triangle somehow. And I'm arguing with you, pick your pencils up now. I'm arguing that this here is 55 degrees. And I hope I turned off the vanishing ink. It highlighted again. It's going to vanish again. I've been through this before on this new software. Okay. Close the program. Bring it back. There we go, Mr. Dueck. So Alex, I hope I convinced you. Now, the trick is, by the way, is extend a little dotted line right there, and then it's a bit more obvious. But I'm arguing that this angle right here is 55 degrees. Not only that, I'm arguing that I have a side, an angle, and a side. This is not SOHCAHTOA, but here's my question. Sine law or cosine law? Cosine, because there's no pair. Okay? What am I trying to find? This guy. Here's the angle across from it. So what's my cosine law going to look like? It's going to look as follows. It's going to be ground speed squared equals this one squared plus this one squared minus 2 times this one cosine of the angle. That's how the cosine law fits from. Remember, it is on your formula sheet. But here I don't have an A, B, and C to make it work, Kelly. I have to kind of just extrapolate the pattern. It's whatever you're trying to find, the angle goes across from it. And the other two sides squared, and don't forget the minus 2. I can go to my calculator and type all this in one fell swoop. Don't forget to square root. Cosine of 55, not 35. Double check. 200 squared, 60 squared, 260 cos 55. Square root of that. The magnitude of the ground velocity is going to be 173 if I go to 3 sig figs. Are we done? Did the question say find the magnitude of the ground velocity, or did it say both magnitude and direction? Well, it asked for the velocity, not the speed. So I think they want me to give it... You okay, Josh? Yep. I think they want me to give also the direction. You make it, Nate? That was a long yawn. Nathan, I think, see my blue resultant? See where it starts out in the triangle? I think the angle that I'm going to want is this one here. That's theta. By the way, if I start like this and go, is that what of what? North of south, east of west, what of what? I'll get the magnitude in a second, but what of what? Start out going north and then go east of north, right? North of east, Elijah, would be start out going east and then go north of east, which is not what I've drawn. I went vertical and then tilted to the left to get the blue line, right? So that's east of, start out going north, go east of north. So I'm going to leave a little space. East of north. What's going to go right here? The angle. Can I use sine, cosine, tangent, SOHCAHTOA? Everybody say no. So what? Sine law.
Wait a minute, Mr. Dueck. I thought you said we couldn't use the sine law because we didn't have a... Oh!
I now know that this is 172.7257 blah, 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 which means now I do have a pair. And I can use the sine law. It's going to be over here on the side. The sine of the mystery angle divided by what's across from it, which is exactly 60, equals the sine of the only other angle that I know, 55, divided by 172.7257. Actually, you know what? I'm going to use the answer button on my calculator when I type in that number there. Yes, Aaron, this is 1 fraction equals 1 fraction. Yes, that means I can move the 60 degrees up in front of the sine 55. Yes, Aaron, I'll get this. The sine of the mystery angle equals 60 times the sine of 55 divided by 172.7257. It's going to be 60 times the sine of 55 divided by, and I'm going to use my answer button so that instead of writing 172.7257, I've got it in there accurately, Kelly, like 50 decimal places. And I get the sine of, Oh, that's the sine of the angle. Yes? How do I find the angle? If sine theta equals 0.28455, how do I find theta? Putting it all together. second function. Second function sine of, oh, are you saying I can use the answer button again? Well, yes, I can. And I get 16.5 degrees. That's an A-level Physics 12 question. Okay? Physics 12, vectors. A-level, non-right angle trig. Did I say I like that question, I like that question, I like that question, I like that question? I did? Hopefully you may have picked something up from that. I don't know, just speculating. Turn the page. I wrote down here, in a moment of unusual mercy, in a staggering moment of softness, that if you're uncomfortable with the cosine law and the sine law, you could do this all using components and SOHCAHTOA. And then I said, this involves breaking every vector up into a Vx and a Vy. And then I wrote, here is the above example done via components. You know what? I'm not going to do it. However, if you're shaky on the sine law and the cosine law, if you come see me sometime in the next 3 or 4 days after school, I'll show you the component method right here. There's room for it in our notes. But I'm going to nudge you. If you feel you're fairly decent mathematically, but you're still finding this tough, I'm going to say, have confidence. Let me nudge you into this, because I'm telling you, it's a huge time saver when we get to momentum and equilibrium, if you can handle the sine law and the cosine law and don't need to go components. So I wrote here, you get the same answer. I like the tip-to-tail method because I'm good at the sine law and the cosine law. But you'll get full marks for any method that you use, whichever one you like best. Next page over. So we know how to add vectors. How do we subtract vectors? The short answer, Aaron, is we don't. We don't. Instead, we turn it into an addition question. Now, I've lied a little bit. There is a way, there is actually, Ashley, an algorithm for subtracting vectors. It's you draw them tail to tail, and then the resultant is from the tip of the smallest vector to the tip of the, whatever. Why memorize? I used to know the rule, and I've forgotten it for the first time in years. Just now I went blank on it. There is a rule for subtracting, but Jordan, let's turn it into an addition question, and that way we don't have to learn something new. And how do we do that, Aaron, my friend? By the way, it's add the opposite of the second vector, the negative, the one with the negative. And I think this is the last one. Yes, it is. Don't worry, your homework is only going to be about 5 minutes. You'll get it done probably in class. So, Michael, if you ask me to go vector A take away vector B, I don't. I say that's the same as vector A plus the opposite of vector B, the pointed in the opposite direction of vector B. So, example 3. A plane's ground velocity, what the radar is measuring, is 240 meters per second due east. The wind is blowing at 80 meters per second due south. What's the plane's air velocity? What I'm arguing, and those of you who are watching this at home aren't going to be able to see this, but what I'm saying is we're seeing the plane traveling, pointing exactly that way, but the wind is blowing this way. I think the plane must be pointing into the wind in order to keep going directly to the east, and I'd like to know which way it's pointing. Does that make sense? As an equation, we already said V engine or V air plus V wind equals V ground. How would I get V engine by itself? Minus VW, V wind. In other words, the engine velocity is going to be the ground velocity take away the wind velocity. Except, Jordan, I don't subtract vectors. What do I do instead?
Add the opposite.
So can I go bump, bump? That's what my picture is going to look like. I got to do a compass rose because I think I've turned the page. So here we go. What's the ground velocity that the radar is picking up? Michael, magnitude and direction.
240 meters per second.
Nyum. What's the wind velocity, Michael? Magnitude and direction.
80 meters per second.
Oh, what's negative the wind velocity then? Magnitude and direction.
80 meters per second. 80 meters per second north.
North. I like this question. I like this question. I like this question. This is a nice question. Why would I say that, Nate? You didn't hear me say that. I'll never tell you if something's going to be on the test. I expect as a good student, you tend to notice if your teacher, emphasizes certain things. Right? Okay. How will I add these two together? Tip to tail, and this one is going to be woohoo SOHCAHTOA, so I can probably do it in a couple lines. It's going to look like this. 240, 80. That there is the plane's that's which way the plane is pointing. That's the engine velocity. It's pointing slightly north and mostly east. Can you do the Pythagoras? What's the magnitude of the engine's velocity? Because it is a lovely right angle. Woohoo! What's the magnitude? Not that I don't trust Michael, but I don't trust Michael. Okay. 240 squared plus 80 squared equals 253. I agree with Michael. Holy smokes. Meters. Is it meters per second or was it kilometers per hour? Meters per second? At. Now I think the theta. By the way, that angle there is going to be what of what? North of south, east of west, what of what? I think it's going to be north of east, opposite, adjacent. Hey, it's tangent again. It won't always be tangent, but Jordan, it'll mostly be tangent. Do you get 18.4 degrees? Right. So subtracting vectors, fair game now. I think on your test there's going to be one subtraction vector question somewhere on there. Okay. Next page. I love Foxtrot comics. The author, Bill Ammond, actually has his physics degree. And in fact, while he was in physics classes in universities, he would doodle quite a bit, and his friends encouraged him to turn them into comics. So what I love about Bill Ammond is the physics and the math in the Foxtrot comics are correct. So I'll be pulling these out fairly often. In fact, I just bought a new annual of his that I got to go through and start photocopying. So here's the first one. Jason, the younger boy, is the wonderful, nerdy kid. I can relate to him, and his older brother. So, Jason, what pattern did I tell you to run? You said, go out 10 yards, then go 10 yards to the right. And what pattern did you run? I went 10 root 2 yards at a 45-degree angle. And are they the same thing? Well, if you had the vectors, sure. This is football, not math class. Why did I get rounded 2 decimal places? So there's the first one. The second one, I have actually ran this play out in the field to confirm the physics here, and the physics are correct. Petra, it says this. Okay, here's the play. Go 40 yards downfield, then turn left and go 20 yards, then turn right and go 25 yards, then turn right again and go 30 yards, then turn right and go 30 yards, then turn left and go 10 yards, then turn left and go 15 yards, then turn left and go 20 yards, then turn left and go 50 yards, and I'll hit you with the ball. And the older brother Peter thinks for a while, and then he says, won't I be right back where I started? And Jason says, I can't throw very far. Peter says, okay, here's a new play. I never get to be quarterback. We have run that play, and all of those vectors do add up to 0 when you run the play. So I like that. What does it say your homework is? It says vector addition worksheet.